Well, welcome and good morning, everyone. It's a pleasure to be with you today. My name is Reed Ryan. I want to thank you for joining us for our webinar today, analyzing petroleum asphalt binder supply chain under our energy transition scenarios. Before we begin, it's my opportunity and task to cover a few things with you. We've budgeted approximately about 1 hour for this webinar, and we have reserved time at the end for Q&A. Speaking of Q&A, we'll go through a couple of the navigational features for you, just so that you are aware before we get into the heart of the presentation today. So since this is in webinar format, as you've probably noticed, your microphones and your cameras are turned off by default and the chat is disabled. However, we do want you to, and do encourage you to use the Q&A feature. So to submit a question, you would click on the Q&A icon in your toolbar, and you can enter your question at any time. We do have a moderator helping us on the back end, and we do want to recognize Jacqueline Bartak here with Asphalt Institute, who has done such a great job for us. She is helping us with the webinar today and will be helping us with those questions as we move forward. So those questions are moderated and they will be published as we move forward, and we'll be able to ask a few of those, both of John and Chait, as the webinar progresses. But you're welcome to at any time click on that icon and type in your question. Now, when it comes to technical assistance, this is always the challenge, but if you are experiencing any audio or visual issues, we encourage you to try refreshing your Teams window or rejoining the webinar at any point during its progress. If the problems persist, those may be a couple of things that might be out of our control, but things that you might be able to check, such as your internet connection or your IT support with your associated organizations or companies. As far as just a notification, we are recording this webinar for the benefit and use of others that were not able to join us today. We're very appreciative of all of you who have been able to join us, but we know there are a few that have conflicts. So this webinar is recorded, and we just wanted to make sure all of you are aware of that. With those housekeeping items aside, it's my pleasure to now dive into our presentation. We can't do that without first introducing you to a couple of key people who will be helping us on the call today. Those folks, the first gentleman, his name is John Browning. John brings over 15 years of extensive experience in the asphalt industry, having held both commercial and technical roles at Imperial Oil, which is an affiliate of ExxonMobil. Currently, John serves as the North American Asphalt Sales Supervisor, and previously he was a Senior Principal Asphalt Scientist at Imperial Oil. In addition to his current role, John is the Vice President of Global Affairs at the Asphalt Institute. He is also chaired at Asphalt Institute Technical Advisory Committee and served as the Institute's Vice President. John has been a key member of the Sustainability Oversight Panel and has chaired the Environmental Product Declarations Task Force within AI. This has all led to his efforts to promote sustainability within our industry, and he has over 10 technical papers to his name, along with several patents related to the asphalt technology. John earned his MS and PhD in organometallic chemistry, which is incredibly interesting, and I want to learn more. He got this from Queen's University in Kingston, Ontario, Canada. So John, thank you for joining us. The gentleman that's joined us with John today is Dr. Chait Bhatt. Chait graduated with a PhD in Civil and Environmental Engineering from Michigan Technological University in the fall of 2020, and he's also a certified life cycle assessment practitioner by the American Center for Life Cycle Assessment. Chait works as the head of sustainability, engineering, and research at the Asphalt Institute, and has previously worked as a research contractor at the Turner Fairbanks Highway Research Center. As part of his work with the Asphalt Institute, Chait is currently chairing the Product Category Rule Committee, which is drafting the rules to develop our environmental product declarations for asphalt binder. Chait also leads our strategic sustainability efforts under the Asphalt Institute Foundation. A recent example of this work is the collaboration with Wood Mackenzie, which we'll be talking about today, analyzing the petroleum asphalt binder supply chain under various energy transition scenarios. I'm very excited for this topic, and I'm very excited to welcome both Chait and John to the webinar today. Chait and John, thank you for joining us. What I do want to say is I will forgive Chait. He actually made me wear a tie today, so I'm dressed up and excited for our presentation and glad that we are all dressed up and able to join you today. As I went through those bios, it was clearly evident of John's involvement with both the Asphalt Institute and the Asphalt Institute Foundation. Before we jump to our first few slides, I would like to just make a disclaimer that John is here representing his views under that hat with the work that he has done with the Asphalt Institute Foundation and not with Imperial Oil. So we're excited to have John join us, but we want to just remind folks that what he will share today is under the auspices of all that work that he has done on behalf of both AI and the AI Foundation. So thanks again, John and Chait, for joining us, and we will jump to our next slide. Hopefully, if I have control. There we are. So this just gives you a little bit of the project overview. We've mentioned the title several times, but there is so much more behind that title. What that really means is that AIF went out and contracted with Wood Mackenzie, which is an international consultant, recognized as top-tier international consultancy firm when it comes to energy transition, and all things that are changing within our world. It's a great opportunity that we had to partner with Wood Mackenzie, and we're appreciative of the collaboration and the spirit which was undertaken through the foundation to be able to bring this study to light. That study was overseen and really been able to provide the adequate feedback and recognition through our AIF Sustainability Oversight Panel, and I'll recognize a few of those folks here momentarily. And then you can see those resources that were noted. These are where a lot of this data and the things that we'll talk about today will be presented to you. I'd mentioned our Sustainability Oversight Panel. These are the wonderful folks that helped us with that. There's too many to name by name, but I will leave the slide up here momentarily for us to be able to recognize that this is a broad swath of AI membership and does represent global representation. Particularly, we would like to recognize our friends at Eurobatoum who joined us in this effort, and we're grateful for the way in which this group, the Sustainability Oversight Panel, led us down this path to be able to come to you today. The next thing that I would like to recognize is a lot of these things do not happen without the members of AI and the sponsorships that they provide to the foundation. So very grateful personally and organizationally from the foundation standpoint for Associated Asphalt and for Marathon Petroleum Company that led us down, that afforded for us the opportunity to have the resources to even conduct this study. Thank you to these sponsors. So with that, I will now turn over to John, who's going to key us up and really set the stage for what it is that we went and looked at with this study. John, thanks again for joining us. I'll turn that over to you.
Awesome. Thank you, Reed. So I'm going to start by talking about what the key challenge was for the AIF in looking at this study. And strangely, the title of the study is really close to that key challenge, which is really understanding what does the potential future of asphalt binder supply in North America look like under the different energy transition scenarios? And to really do that, what we had to do is understand the rate and pace of that expected energy transition, and then understand what that pace and rate meant to how different scenarios would change the dynamics of the energy supply world. And that really covers the two boxes on the left-hand side of this chart that's going to form the basis of the discussion that I lead in this webinar today. And then Chait, later in the discussion, will talk about the third box. So before I move on to the next slide, I want to really talk about them. I'll talk about the methodology of the study in a little bit, but I first wanted to do a very high-level overview of the petroleum asphalt binder manufacturing process as a very quick introduction for the broad group of folks that has joined our webinar. So if we can go to the next slide, Chait. What this shows is our asphalt binder manufacturing process at a very high level. Petroleum crude oil is used as a feedstock in the refining process, and that crude oil is passed through two distillation columns, an atmospheric and vacuum distillation column, that separate lighter molecules like gasoline and diesel for use in fuels and other products. And as that distillation is complete, you're left with a material called a residue, a vacuum residue, or a resid. Now that resid can be sent to other upgrading units like a coker and be turned into other products like fuels or other products. It can be blended into heavy fuel oil, or if it has the right qualities, it can be used as an asphalt. And that asphalt may require further processing of blending or additives to it to get it to the right specifications that are required. And this is a very simplistic view of our, call it cradle to gate within the asphalt refinery for the production of asphalt binder. And I really want to tie into that crude oil piece. So the dynamics of this and the refining industry are tied to the energy transition. So understanding this and understanding crude oil demand and other product demand, petroleum product demands, is critical to understanding what is required and what the supply scenarios look like for asphalt binder, because it is integrated with the rest of these materials and their uses. So that's critical for this slide and what we do. Now, switching gears a little bit and talking more specifically about the study, Wood Mackenzie has an energy outlook. And what they have done is they've modeled a base case scenario that takes into account a number of different elements. It takes into account supply and demand elements across various sectors, understanding what technologies exist, what technologies could exist in the future, and what the economics of all of these processes are, and what is required from a carbon emissions standpoint. It uses these to build a base case model and then looks at other scenarios to go and build out what that energy outlook scenarios look like under those different requirements within the system. We're going to talk about three that I'll cover on the next slide. There's the base case, there's a pledges scenario, and there's a net zero scenario. And these are laid out here in this chart in the three separate columns. These scenarios are consistent with the International Energy Agency's third-party reviewed scenarios. And they're related to carbon or global warming potential in each of the scenarios. And you can see that in the top of each chart. For the base case, global warming is limited to 2.5 degrees Celsius. In the pledges scenario, it's 2 degrees, and the net zero, 1.5. Each of the charts in the top shows the equivalent carbon dioxide emissions under the scenarios to meet those global warming potential targets. We will use these terms and these terminologies throughout the rest of the discussion. So I did want to highlight each of them. And as we go to the bottom of the chart, each of these shows the key metrics and what would be required to get to those scenarios out to 2050, from an investment perspective, from a power mix perspective, from an electric vehicle perspective, and a price of carbon perspective. Okay. Now, one other element I did want to highlight in 2023, when we started this study, the Wood Mackenzie Energy Outlook stated that the base case scenario was the most feasible scenario for the energy transition based upon the current realities of the world. More recently, in 2025, there is another scenario that has been generated that is a delayed base case scenario that has a global warming potential limited to 3 degrees Celsius. And that's due to many of the geopolitical tensions that have been generated over the last year and a bit. I'm not going to discuss that in great detail. It wasn't part of the AIF Foundation study, but I did want to put that there as a piece of context for these three scenarios and the likelihood of what transpires over the next number of years out until 2050. Okay. So we understand the magnitude of what's required to get here. We understand what it's going to take and how these scenarios are generated. I did want to touch on the pledges and net zero scenarios a little bit to talk about how Wood Mackenzie's energy outlook has built those up. And if we go to the next slide, what we see on this chart is a map of the world with the various pledges that have been made by country and their state of implementation, I'll call it, around the world. So what it means is the rate and pace of this energy transition will occur at different paces in different parts of the world. On the chart or the table on the right-hand side, we see the announced pledges for a select group of countries, what that means from an emissions perspective versus their 2030 target versus their baseline, and when they would expect to get to net zero. Okay. And this information informs the models and allows those pledges and net zero scenarios to be generated within the Wood Mackenzie Energy Outlook modeling. Okay. I think that's critical for understanding how and what these different scenarios are and how they're built up within Wood Mackenzie's model. So we've gone through an introduction to the energy transition and outlook scenarios used by Wood Mackenzie. We've covered the asphalt binder manufacturing process. And now I want to transition to the outcomes of the energy outlook and what that specifically means to the impact on crude oil demand, by scenario, because again, tying back to what I talked about, crude oil and the refining and petroleum industry is going to be critical to understanding our asphalt binder manufacturing. This slide details the global oil demand outlook by scenario on the left-hand chart. The base case scenario is the one at top in brown. The red is the pledges scenario, and the green line is the net zero scenario. Each of these, the vertical axis shows petroleum demand or global oil demand in millions of barrels per day through 2050. If you can look at the base case scenario, you see it slowly increase out until about 2030. Then it begins a slow decline out to 2050. The pledges and net zero scenario are more aggressive on the demand destruction on the crude oil side of the barrel. Now, when we look at what happens and what's driving that in these various scenarios in 2050, the chart on the right-hand side of this slide, again in million barrels a day of oil, details the breakout by sector where that oil is used in the base case, in the pledges, and the net zero scenario. And what we see is the biggest implications as you move from scenario to scenario are in the road transportation and the industrial use sectors of these charts. And I'm going to focus a little bit on road transportation, where we see gasoline demand destruction or road transportation fuel demand destruction driven by changes in the vehicle fleet, which I want to cover on the next slide because there's an important implication to roads and our road network. But that's really what's driving the change in the demand scenarios and gets us to the different outlooks driven by the Wood Mackenzie modeling. So if we go to the next slide, this slide details what the global vehicle fleet will look like in the base case scenario out to 2050. And what we see in this scenario is a growth of the vehicle fleet to 2050 of over 50%. And a significant portion of the global passenger vehicle fleet electrifies. The heavy duty fleet begins to electrify, but it occurs at a slower pace than the passenger vehicle fleet because of the energy densities and the mileage required in that heavy duty fleet. And so that changes the fuels demand scenario and lowers that going forward as we change energy sources for the vehicles. But what's really critical to me and for our asphalt industry is that the vehicle fleet continues to grow. So more vehicles, more people and goods to be moved. So we need to maintain and improve our road networks, which ties to the demand scenario of asphalt and asphalt binder production in this study. And I think that's really the important implication that I want to walk away with, is this is part of the reasoning behind how the energy transition occurs and what the implications are from a petroleum demand perspective in each of the scenarios, but what it means to the road industry. Now, if we go to the next slide, we're now coming in specifically to asphalt binder demand and that element of the study. So taking the energy outlook and going right down to the level of global asphalt or bitumen demand. The chart on the left shows our global demand by region in millions of barrels a day, forecasted out to 2050 in the base case scenario. What you see again in the chart is that demand grows out to about 2030-ish and remains largely flat out until 2050. When we transition to the table or the chart on the right-hand side of this slide, what we see is the overlay of the bitumen or asphalts industry's contribution to global oil demand. That's thin pink slice at the top. Asphalt demand today and out to 2050 really represents about 2% of the overall petroleum barrel. So it doesn't drive decisions broadly across the industry. It's an important part of the barrel, but it's a small part of the barrel. And that's important to understand what this means for the future of binder supply and the choices that will drive that in the future. Okay. All right. Now, changing gears again a little bit, what this shows is what was shown on the other chart, but specific to North America. So the binder demand balance by each of the scenarios. The yellow circle at the top represents our demand for asphalt binder in all of the cases. You'll notice that that is consistent across the base case, pledges, and net zero case. That's because we still need our road network. We still need materials to pave with. And so that demand, unlike other petroleum products, doesn't change in the same way for asphalt binder. This chart does take a snapshot at 2040. Just wanted to make sure that I declare that versus what was shown on the other chart out to 2050. So we're looking specifically at 2040 as a snapshot here. When I look at the base case, all of our binder demand is met by existing supply. When you go to the pledges in pink or the net zero case in light blue, there's a gap in supply versus expected demand. And that doesn't mean that there won't be supply. It means that it will come from different sources than existing supply today. Okay, I want to make that absolutely clear. This is just saying that based upon the transitions that we would expect in the energy outlook from Wood Mackenzie, that the sources that produce today would change. And so the next portion of this is how is that supply gap filled? What are the options and choices that we have to fill that gap? And Wood Mackenzie, through their modeling efforts, went and looked at a bunch of criteria to try and understand in the pledges and net zero scenario, what were the most likely ways of fulfilling that demand that is required for our road networks in North America. They looked at all of these aspects: product quality, the economics of production, emission abatement potential in those scenarios, which is critical to how you get to global oil demand. What's the security of supply? What's the readiness of this technology? And will the logistics allow you to get the materials to market? And they looked at this and they modeled a number of different choices and scenarios that led up to a list of 6 ways of meeting that supply gap. And I wanted to delve into those a little bit on the next slide. And so this is the way that I could fulfill that supply gap in the future across my energy transition scenarios. I can shift the yields at the refinery to increase the binder production at existing facilities. I could convert units at existing refineries, potentially turn off a coker as an example, and use that material to make asphalt. I could build new standalone asphalt binder capacity that really has a lower emphasis on fuel production and makes asphalt specifically as the primary focus of that facility. I could also increase imports from around the world, and specifically in this case, they highlight Latin America. But today, 15% of the asphalt used in North America comes from used in the United States is imported from Canada. So asphalt imports do occur today and would occur in the future. You could look at additional feedstocks as a binder extender or replacement. And you can look at increased recycling of used asphalt binder as a portion of the ability to supply that demand gap. And each of these was looked at and ranked based upon their scale and feasibility of being able to meet the supply chain characteristics and product requirements in the future. And out of this, the most favorable elements were deemed shifting yields at refinery through feedstock and process changes and new standalone bitumen capacity. But you can see the ranking across these ranges and where they fit out of the Wood Mackenzie study. So that covers holistically, the story of looking at what are the energy transition scenarios. What does that mean to the petroleum crude oil scenario? What does the pace mean for the various scenarios? And then translating that right through to asphalt binder supply under these different scenarios, and understanding then what are the implications from supply versus what exists today, what would have to happen in the future to allow that to occur. Chait is now going to take the second portion of the talk that really talks about in those worlds where you have, and those scenarios where there is a, global warming potential limit. We talked about those in the scenarios. Excuse me. He'll talk about what your choices are around emissions, potential carbon emissions from asphalt binder production and use, so going beyond the gate, and what that means under each of the scenarios. So Chait, I'll leave it to you. Thank you.
John, thank you so much for setting the stage and the foundation required for the study. That was very insightful. For those of you who already know me, you might know how passionate I am towards life cycle assessment and applying it to pavement context. So in today's discussion, what I'll be delving in the next few slides is two case studies. Firstly, how important is the road that's built to last longer on your potential carbon emissions? So relevance of your key decisions made during the road's use stage. And the other is John mentioned about three different scenarios, energy transition scenarios, right? So what if we do a prospective, like a futuristic life cycle assessment for pavements to look at these potential carbon emissions? So for my LCA nerds in the audience, I know we have a wide variety of audience today. When I say carbon emissions, this is the aggregated metric of methane, nitrous oxide, and other greenhouse gas emissions, what we typically refer to global warming potential. So that's what I'll talk in the next few slides. However, before going into the actual case studies, like the two that I talked about, let's set some stage because I know there are audience coming from the upstream supply chain participating in this webinar, as well as third-party stakeholders. So for those who might not be familiar with our pavement or road arena, this is what we refer to as a life cycle of a road or a pavement. So it starts all the way for asphalt pavement, which is our interest here. As John mentioned, the cradle, it starts all the way from crude extraction to the transportation to the refineries, and then to terminals, use of various additives like polymers, then to a hot mix asphalt plant where it's the liquid binder is blended with aggregates at higher temperatures to make it compactable. That's transported by a contractor, laid it down. So that might be a new construction. But once it's done, then it's exposed to traffic, climate. So there is your pavement and vehicle related interaction and the indirect emissions, what we call operational emissions from the actual vehicle use. But then there's also emissions from the maintenance activities. So depending on how bad your road is, a public agency who are the owners of the roads, like the State Department of Transportations, might decide to do different preservation maintenance treatments to make sure that the road is suitable for user. And at the end of life, like once the pavement reaches its capacity to maintain the functionality for which it's built, then it might be recycled. Asphalt pavement is the most recycled product, as you might know. So it might be recycled or rehabilitated or completely reconstructed. So when we talk about cradle to grave, this is the terminology we use within the life cycle of pavements. What we are covering is everything from crude extraction till the end of life of a road. Now, in the case studies that I'm talking about, we did not consider the operational carbon emissions from pavement vehicle interaction. That's an evolving landscape, and we'll deal with that once there are, like say, strong consensus within these public agencies. But what I'm going to focus on, and given like in a developed country like United States, we might not see many new roads being constructed. But what we might see is preservation, maintenance, rehab of existing roads. So let's focus on that. I promise this is not a snapshot of blueberry cheesecake or a blackberry cheesecake, depending on however you're seeing it on your screen. So for non-pavement or non-civil engineers, when we drive regularly on our roads, all we see is the surface layer, right? But when you actually cut the cross section of a road, depending on which type of road you're driving on, an interstate or your local road, it would look something like this. At the very bottom will be your crust or the subgrade or soil that will provide stronger foundation for your entire pavement structure, followed by from the bottom the subbase, which is made of coarser aggregates, and then your Then comes your asphalt structure, which can be classified into asphalt surface on the top that's directly interacting with your vehicles and exposed to climate. And then also asphalt base that is a mixture of asphalt aggregates and other things. Now, I would like to firstly give credit to our partner organization, Pavement Preservation Recycling Association Alliance, who have put this very cool website. So this is a screenshot from their website. But what this website actually gives you is, depending on what type of pavement owner you are, you might own a parking lot, or you may own a local road, or maybe looking after your state network. You can go in and input different kinds of de-stresses or failures within your roads, and then select what's your suitable combination. Now, I mentioned three terms in the use stage: preservation, maintenance, and like say major rehabilitation, right? So on the left here, what you see in the blue are mostly surface preservation treatments. So let's say if you're seeing any cracks on your road just as you are driving, or when a state assesses the road's condition, in order to extend the service life of that road, to make sure that that crack does not propagate deeper, as you might see here, just want to give an insight. This is not how our asphalt road looks. All these cracks are made just for educational purposes, okay? So don't perceive that all of our asphalt roads are this bad. So the depending on the depth of your cracks and where you have to use your some of the seals that are mentioned, your preservation treatment could be carried out. Then comes some major rehabilitation treatments where it's not just the asphalt surface that might have to be taken out, but also your subbase. In some cases, you may even have to stabilize your subgrade or soil. So there comes your full depth reclamation or other major rehabilitations. But thinking of this, as John pointed out, we are the Petroleum Asphalt Binder Association, right? So our members manufacture liquid asphalt as well as the other additives like polymers and other additives that go into the binder as a whole. But in order to actually get a holistic picture about our supply chain, it was not just important for us to listen to our industry, but also listen to the public agencies like the State Department of Transportations and the federal agencies who actually use our product. So what we did during the project is, for the actual use of these roads, let's ask the agencies on what they are prioritizing, right? And I won't be providing all the codes, but in this slide, just three codes that I have, and we are not naming which state agencies are those given the sensitivities, as well as pavement contractors and the material manufacturer. Two themes that were pronounced through this was, firstly, the local agencies as well as the state agencies will be prioritizing pavement preservation. That is to say that they are prioritizing to extend the service life of existing roads before they can actually go in and take out the whole road. So that is the first important theme. Second important theme is, for any major rework that they have to do, they are planning to do something that would last for longer. Like 40 years is just something that was quoted here. So from these interviews and the stakeholder insights, for our first case study, we were able to come up with scenarios where we see how does introduction of pavement preservation affect your overall carbon emissions. Second, let's say if I'm using some higher quality materials, like a polymer modified binder with the regular pavement structure and preservation, what would be the carbon emissions in that case? Sorry for this busy slide, but this is before going into the numbers, because for me, while doing an LCA, I tell all the students that are currently working on life cycle assessment, don't focus on the end results, focus on the hypothesis and assumptions behind your numbers, right? And for the public agencies that might be listening to this webinar, Asphalt Institute throughout has been supporting context-specific pavement life cycle assessments. What I mean by that is, what might work for your Indiana roads might not work for your California roads, or might not work for your Minnesota roads. We are doing this kind of pavement LCA as a snapshot in time analysis, and not to say that this is the universal solution. So the owners of the roads at those respective agencies should make sure that this kind of an analysis is done whenever they are trying to incorporate potential carbon emissions within the decision making. So 3 examples. First example is, I mentioned before that asphalt is the most recycled material, right? Asphalt mixture. So first example is what we typically see within a state agency. Um, let's say there is a new road construction that happens at year 0, and they wait till, let's say, it fails. Like when I say fails, the whole asphalt surface kind of degrades to like 2 inches, 3 inches, 4 inches. Then they go in and take out that asphalt surface and then pave it back again. That's what we call mill and fill rehabilitation activity. So in the first example, what we are looking at is new construction and then mill and fill at every 9 years. There is no preservation, there is no use of polymer. And at the end of life, once the pavement reaches its actual functional life, it's going to be taken out from the entirety. You saw that whole blueberry cheesecake section again. So you'll have to take everything out and then rebuild your road. That's what we call full depth reclamation at year 50. Now, the new construction and the full depth reclamation are going to be the same for all the 3 examples. What changes is in the example 2, also the other thing is the mixture that's initially laid is a mixture that's mixed with 22% of recycled material for both example 1 and example 2. In example 2, we introduce a preservation treatment called slurry seal at year 5. So let's say the agency is doing its evaluation every 2 years, and they feel like the 5th year, we need to do a slurry seal so that I can push out my mill and fill to year 15 instead of year 9. So this cycle continues till year 50. In the third example, what's different is we are not using any recycled material, but the actual binder. So John mentioned about liquid asphalt, and once liquid asphalt comes out of the refinery, it goes to a place called terminal. What happens at a terminal is your asphalt maybe is stored at higher temperatures, but also mixed with different additives. Now, why are we using these additives? One example that I can provide here is a polymer called styrene butadiene styrene that's being used across different public agencies. So what the styrene butadiene styrene polymer gives is both rubbery and plastic-like features to your liquid binder. So it makes it more resilient to higher traffics to higher, let's say, to higher temperatures. So in the third use case, the assumption that we have done there is instead of your slurry seal at year 5, as the example 2, your slurry seal would be at year 7, and your mill and fill would get pushed out to year 20. Looking at these 3, so the previous slide told you about what the agencies are going to be prioritizing, right? In this slide, taking those agency insights, we came up with 3 case studies. So let's see how, from an environmental sustainability quantification perspective, what the agencies are thinking, is that making sense or not? Turns out our public agencies are right. So example 3, for all the 3 examples, what you see is material production is same for 1 and 2 because both 1 and 2 use asphalt mixture with 22% RAP, and end of life, both of them use full depth reclamation. Now example 3, then that's why they have 284 tons of CO2. And for my LCA nerds, the primary data, secondary data, so the design assumptions that we have made here for this analysis is 1 lane mile of road, 12 feet wide, 9-inch depth. If you have more questions, reach out to me personally. We can talk more on the primary, secondary data portions. But what's to note here is in the example 3, the initial material extraction is higher because of the use of that polymer. But what's that doing is in the use stage, it is requiring lesser preservation as well as lesser rehabilitation. So when you look at the cradle to grave emissions, your example 3 turns out to be the most sustainable option, right? So what our public agencies are prioritizing in terms of preservation and longer life seems to be the right option, even from an environmental sustainability quantification perspective. So that's case study 1. Case study 2, John talked about 3 different energy transition scenarios, right? So within the 3 examples that we talked before, let's take example 2, where we are using 22% RAP asphalt mixture, slurry seal at year 5, using the existing practices of asphalt binder production and use. All the fuels are the same, all the construction equipments are the same. This is what we get. Like 505 is like the overall cradle to grave emissions. Another key thing to notice here is your use stage is the predominant contributor when you look at your cradle to grave. We are still not including the operational carbons. This is just the use stage from the actual treatments, but that's what your number looks like. Now, when I do a prospective kind of a life cycle assessment, in order to do that, let's first look at assumptions, right? Now, energy transition scenarios in the pledges case, net zero case, what are those things that will change? These, like, there are two portions to it. One is during the asphalt binder production, all the way from your crude extraction to your refining to your terminal. So during those, things like electrification of your platforms of crude extraction, as well as drilling equipment, use of carbon capture sequestration technologies, or from Canadian oil sands, let's say if they are using some solvents, all of these would McKinsey projected that these will reduce the carbon emissions. Now, during the use, that is mixing with aggregate as well as paving it and then maintaining it, there are multiple options there as well. One thing I would mention here is each of these options, not everything is of the same feasibility level, right? Each of them need different economic incentives, different technical feasibilities. For the sake of our analysis, these are the options we are considering to see how much are we able to reduce from the state of the practice for that example too. In this very busy slide, the things to actually take from the busy slide is, if I do just the base case, so Wood Mackenzie told us that base case is the most likely scenario, right? From the asphalt supply perspective, we are still able to reduce up to 24% of emissions. And that's from your technological innovations in your crude extraction all the way to your grade. But when you look at the net zero, from all the options we talked in the previous slide, we can reduce up to 58%. Now, one thing that I will mention here is we have not considered the use of any bio-based additives in our analysis, so that contain biogenic carbon. So for our snapshot in time analysis, we considered everything that was standardized as of now, like for which material specifications are standardized and practice is standardized. So in future, if there are any bio-based additives that are used, that might reduce the number more. But this is from our analysis is what we see that from a cradle to grave perspective, this is the potential emission reductions. I'll now pass on to Reed to conclude our presentation.
Thanks, Chet. I appreciate that. And as we kind of have this slide up here for everyone and we review what's been presented here to us today, I think there's some fundamental, assumptions that we can make as far as just the concluding thoughts. I want to get to a few of those in just a moment and ask a few questions before we get to that. But here you have an understanding, if you will, right, that the base case is our most likely scenario that was closely examined. That asphalt binder will remain, in demand throughout this transition and shift, and that the supply should remain relatively stable under that base case scenario, which I think is good news for all of us. And now the opportunity lies with refiners, right? When we talk about upstream, about what their choices are before them. And obviously the economics of all of that will drive those decisions. But the good news for us is that, as John mentioned in his portion of the presentation, we still are part of a world that relies on roads, and those roads play an integral part. And asphalt obviously plays, over a 90% part in the construction of most of those roads. And that's a great opportunity for us when you consider, 94% of the roads are built in asphalt in the United States. So the converse of all of that is, can we do better? Can we continue to progress as an industry? And Chait really took that, by the reins and laid out for us an opportunity of various things to consider when it comes to our carbon emissions. And there you have some of that data that's presented before you. So the key takeaway for me in all of this is that it takes all of us. And it's interesting. It's an interesting thought as I ponder this, 2% of the barrel, if you will, that so much in that 2% is driven by 100% of our industry, and all of the things that we do together collectively, from the design and engineering to the construction to the use to the preservation and maintenance, and then to the recyclability of the product, of which we have all made our careers out of, and all that we consider with that. the takeaway for me is that it will take all of us. And this is the opportunity that I think has been presented to us. So John and Chait, I'd love to defer to you if you have any additional concluding thoughts. Otherwise, I'm going to talk a little bit about some questions that Jacqueline has helped supply over to me as you were speaking, and then we can take it from there if you all want to share a thought or two, and then I'll ask you a couple questions.
No, Reed, just one thing to add, and John clearly elaborated it. The main metric to consider, and I'll go back to that slide here within the three scenarios, is the economic feasibility and the amount of incentives required, right? So the ever-evolving market, what we see here is if you would need like $55 trillion for your base case. And for your true net zero case, you'll need like 78 trillion. And that's like cumulative investment between 2024 to 2050 by globally all countries. To give a context of what that looks like in global GDP wise, US's GDP was 23 trillion in 2023. And for a country like India, where I originally come from, it's 3 trillion. So it's the feasibility, the Wood Mackenzie's projections are based on the economic feasibilities as well as the technical innovations that are parallel to those feasibilities. So that's very important for us to note. So John, if you had anything to add to that, yeah.
Nothing to add.
Awesome. John, if you will, I'm going to try to logically order these questions as best I can. I do my best to be a good moderator. As mentioned, Chait made me dress up today, so I feel even more important with a suit and tie on here. But I'm going to try to do a good job. I'm going to try to get these kind of in a logical order as we've had a few questions come in. So why did the study consider energy transition as the starting point? John, you have a lot of perspective. You've dedicated a lot of time both through AI and through the foundation. You're here representing those thoughts, as a member of those organizations. Why start here as the transition, energy transition as a starting point?
Well, I think that's going to fundamentally change what the energy picture looks like in the future, right? I talked a little bit about the tie of asphalt binder to petroleum refining and to crude oil, and all of those things are interlinked. So to really understand what the world looks like in these different scenarios, you need to start there. You need to understand the energy outlook. You need to understand how those energy needs are going to be met. And then you can translate that back through the system into the end product like asphalt. So I think that's really why you've got to look at these scenarios and why asphalt binder is so linked to the energy transition.
Thanks. And this is kind of a good related follow-up question that's here on the Q&A. So I had mentioned Wood Mackenzie, why that selection was made, for reputation and the quality of the partnership. And that was, I think, evident in what has been supplied here today. But how closely, John, do you feel that aligns with what else you're seeing, in terms of the projections, like let's say the International Energy Agency and others? Like, do you feel, John, as a respected professional in this industry, that what you saw, hey, I'm seeing this elsewhere, it feels as if there's momentum towards this or an understanding towards this? If you could provide some perspective.
Absolutely. I think, if what I would ask the folks in the webinar to do is go and look at what other energy outlooks are out there. I know my company publishes the ExxonMobil energy outlook. It lists the range of scenarios. This fits the base case, and the pledges and net zero scenarios would fall within that range. I think I don't have an exact comparison, but go look at the other available material out there. Compare. These are scenarios. These are modeling choices. These are things you can go and compare one another to. And I think this is well within the range of other studies and other outcomes that looks at this energy transition and the pace. And I think it's absolutely credible. And it's one look and one view and one opinion of the world, but it's within what is out there in the literature. Chait, I don't know if you had anything to add or.
Yeah, Chait, any thoughts you'd like to add to that?
Oh yeah, so International Energy Agency's outlook would be a very good report if folks feel like, okay, this is an association that contracted this consultancy and they gave them the numbers. I would highly recommend you to go to International Energy Agencies. That's a third party which is verified by even Department of Energy and other global stakeholders. Look at the numbers of their transition scenarios, the economic incentives associated with them, and the feasibility. You would find similarities close to what we have assumed in our analysis.
Awesome. Thank you both for those thoughts. Chad, I'm going to transition to you to, I think we've kind of talked more globally, right, around a big picture. I'm going to jump to very specific, I think, good question that's come in. What's the impact of electric vehicles, right? So has the study considered, electric vehicles, there's a weight shift in terms of the vehicles in and of themselves. Was that looked at in this? Does the wear and tear associated with that play into the study, or for future questions? Do you have perspective on that, Chad?
Oh, yeah, that's a great question. And that's definitely something to be considered in the future. I know there are researchers within United States and globally right now looking at, to name a few, don't want to limit to any, but University of Illinois, Urbana-Champaign is doing some great work looking at the different electric vehicles like trucks as well as passenger fleets. The In our analysis, we did not. But moving forward, and also from Poland, I recently looked up a study that is even looking at rolling resistance. Does the pavement vehicle interaction, how would heavier electric vehicles actually result in higher rolling resistance or lower? That would lead to higher energy consumption. But as I pointed out during my initial hypothesis, this is a snapshot in time analysis. And what we encourage different stakeholders is to do their context specific analysis before coming to decisions. Let the data speak for itself. And that's been our mantra throughout.
Awesome, thank you. So I'm gonna give another one here, Chad, up your alley, if you will. So, what were the assumptions around? So, anytime we try to gaze into a crystal ball, right, you do have to make some assumptions. If we all could predict the future perfectly, we probably wouldn't be doing the things that we do. But here we are. We're looking into the future. We're gazing into the crystal ball. We do have to make a few assumptions around that. The study, I am assuming, Chad, maybe if you can give some insight in terms of the life cycle of the actual roads themselves, what were the assumptions? And if there were innovations that would come forward that maybe we're not considering or maybe not even, on our radar screen yet, how does that change your outlook on all of this?
Sure. Yeah. So for our context specific study, the foreground system, what we use the terminology within life cycle assessment, we used a peer reviewed journal publication from Michigan State University that actually simulated pavement service lives using context specific mechanistic ME, which is from AASHTO has developed this tool. And so they used context specific material calibrations when developing these service life projections as well as treatments. But as I said, it's an ever evolving, you can't, so if like a ideal solution would be to have a dynamic sustainability assessment tool in the future that would take into account all the innovations that are happening at the same point within your traffic arena, as well as your material and design computations, and then spit out your life cycle assessment numbers. Unfortunately, we don't have one right now, but hopefully in the future, someone comes up with that and we'll have more dynamic sort of analysis being carried out as the innovations come into the market.
Great, thank you. That was a good answer to a very loaded question. Well done. Appreciate that. This next question, Chad, I think what you will help us because you were involved in a lot of the I think considerations. This is along a similar vein, and I think it's one of those. I don't want to call it a myth, but it's one of those persistent rumors, if you will, within our industry that all we experience is continual refinery closures, right? And if you look at the data from the last 20 years or so, what there have been refineries that have closed. Yes, that is a given fact. There are refineries that were producing asphalt that have closed. Yes, that's a given fact. What I was surprised as I came again as the newest employee here to the Asphalt Institute is that number is actually much smaller than I would have actually thought in my mind. That I think the total number is 5 over the last 25 years. There's refineries that were producing asphalt that are no longer producing asphalt. So as we consider that, there is obviously that greater potential out there for either consolidation or market dynamics change. As we currently stand, my interpretation of our supply in the country is this is not a supply issue, right? The demand is really what drives these decisions. And there is additional capacity available within our structures as they currently are constituted. However, it's a good question that looking forward, did Wood Mackenzie, as you consulted with them or others on the sustainability oversight panel, provided feedback? Was that talked about? I wonder if you could give us insight into that other glimpse on the other side, upstream, the future.
Yeah, it was a very granular. So in the 1 hour time that we have, Oh, someone's joining now. I think they might have missed the most of the things. But in the 1 hour time that we have now, we had to cover the breadth of the topic. That's why we didn't go into the depths of each of them. But specifically looking at upstream, Wood Mackenzie did look at the granularities of different crude extraction. First of all, those supplies available for crude, all the way to different pad regions within the US and for the North American context. How are those going to look like, right? We did do even a piece on Western Europe. We did not present on that, but major focus was on North America. So all the granularities of geographical as well as technological feasibilities and the movements were considered by Wood Mackenzie when doing this analysis. So this is not out of thin air. All the inherent assumptions that we have done were not plugged out of thin air. Yep.
So I wonder, Chait, along that same line, for those folks, the refineries that are in existence, the actions that they're taking, does anything come top of mind? This is a great question of the real world examples of the ongoing decarbonization efforts. Anything come top of mind for you as far as these actions that are already taking to affect the emissions as you kind of ended your portion of the presentation?
Oh yeah. So that's again a loaded question, but I look at it from two perspectives. One is a collective effort and then the individual efforts, right? So for asphalt binder, if you look at our 2019 cradle to gate life cycle assessment study, good portion of it came from Canadian oil sands. Now, 95% of the oil sand manufacturers have pledged to net zero by 2050 through this initiative called Pathways Alliance. Okay, so you can go and look into their website to look at potential carbon capture, sequestration, and utilization, and the funding that they're providing for that particular initiative. Now, on a global level, 12 CEOs of different oil and gas companies pledge, I think, $7 billion each year as part of Oil and Gas Climate Initiative to look at not just carbon capture sequestration, but also futuristic things like direct air capture and others. Our own members individually have pledged differently based on their individual capacities of economic feasibility and technological availability or to different decarbonization initiatives. So if anyone has any specific questions, I'll be more than happy to provide them more information on these collective as well as individual efforts. But the short answer is yes. It's a lot happening right from the upstream industries perspective on decarbonization, not just within our own alley.
Thanks. And we only have just a couple minutes left. So John's getting off easy. Chait, I continue to pick on you for making me dress up. Here's another one for you, Chait. One of the things that's fascinating to me, and I think it's a shift within our industry to talk about this entire life cycle, right? And the durability of payments around the entire life cycle. Part and parcel of that is getting good quality data to make those best decisions. So as folks are, I think, and that's really kind of where we're at, is making sure that, hey, we have this complete picture out there. Let's make sure that we supply the right data around that so that the best possible decisions are made. So, and if you look at those examples and we're only to take them out of the gate, then you end up with, you end up in very different places if that's all you're looking at. And I think you pointed that out very well, and you gave the right disclaimers and you put the right stipulations around that. So thank you, because it is all highly dependent and it's contextual. But as we venture down this path, are you aware of real world examples? This is the question here about people looking at that whole life cycle and the durability of the payment as that complete picture. Are you aware of any real world examples?
Yeah, I don't want to point at any specific things, but the 3 state agencies that I know right now who are working on integrating, there are 3 state agencies right now who are trying to integrate their material databases based on which they do the procurement decisions, and then their payment design databases. So that whole cheesecake design to do that. And then also to monitor your long-term performance, your payment management system database. So the very high quality data would be the actual performance data that you would see from the field, right? Because most of the times what people do is simulate through laboratory or design softwares on how that material and design combination will perform. So 3 state agencies are currently trying to integrate those different databases. So the high quality inputs would be the ones that feed from that payment management systems on not just historic performance, but if they're using new materials and innovative materials, there needs to be standard, very detailed payment design models too that would inform those. To Academic institutions that I would highly like to point out to. One is I did mention about University of Illinois Urbana-Champaign. They have developed a life cycle assessment tool for the from the funding from Illinois, but also University of California Pavement Research Center has developed a specific pavement LCA tool for California Transportation Department. So the way to go with it, a lot of the policies sometimes look at just cradle to gate, but as you saw from the analysis, cradle to grave is the right scope to actually look at the hotspots and identify solutions. So just looking at cradle to gate might not give you the whole solution. So that's what I'd like to point out there, Reed.
Awesome, thank you. We're at our time, our top of the hour, so I'm gonna try to wrap things up. John and Chait, thank you very much. We appreciate your time for today. We won't be able to get to all the questions. I apologize to those folks I wasn't able to get to your questions, but hope that you will reach out to us either individually or collectively. We'd be happy to chat with you on those. This presentation is recorded, and Chait, do you want to mention it'll be available for folks to view for those team members or others that weren't able to join us in person here? They'll have accessibility. Am I correct there, Chait?
Yes.
Awesome. And then I think what I'll do is tee up. There's a great question talking about was biobinders considered and what does that mean? And I think that is a great question that kind of points to why we go about doing this work, both through the foundation when we think of a strategic direction and through AI, through a tactical route in terms of understanding what our world will look like and how these things are shifting. So I think to that question, I would say stay tuned and hopefully we can help provide some answers as we move forward, either from a tactical perspective or a strategic perspective, as we try to help become a resource and continue, the legacy of the foundation and the work of Asphalt Institute in this realm. So Chait and John, thank you again. Appreciate all the work that was culminated in the webinar today. Jacqueline, want to say thank you as well for your great work and helping to keep things running smoothly for us. And we appreciate all of you as attendees for joining us and for sticking with us this long. Hopefully you'll all be able to go enjoy a little bit of March Madness now. And we appreciate you joining us. Have a great day, everyone. Take care.
Thank you.
Thank you, Reed.